Let's talk about level 3 subtraction strategies. The first one I want to talk about is similar to the make 10 strategy for addition, but we're going to think about take from 10. So it's the idea of decomposing a number to find an easy subtraction problem that we can do mentally in our head. Although first, we're going to record our thinking on paper. So let's think about how we could model 15 minus 6. We're going to start with cubes just like we did for addition. To model and practice this strategy, we're going to start with 15 minus 9, and we're going to use cubes to show our thinking first, just like we did with addition. So in addition, we were thinking about how we could decompose an add-in to make a 10. With subtraction in the take from 10 strategy, we're thinking that this 9 is really close to being a 10, right? It's almost 10. And I could count back 9, but that's a lot to count back by, and I'm very likely to make a mistake. I also can think about 15 is made up of 10 and 5. And because I know my partners to 10, remember how important that is, I know if I think about taking the 9 from the 10, I don't have to count back. I know 9 just needs one more to make 10. So I could take away these 9 all at once and see that what is left is 1 and 5, which is 6. So let's think about how we might write that to show our thinking using equations. I started with 15 minus 9. I thought about 15 as being made up of 10 and 5. I did 10 minus 9 and was left with 1, and I know 1 plus 5 equals 6. I could also write it over here. I like sometimes to circle this to show I took the 9 from the 10 and had 1 left, and then I can add up my parts that are left. There's my 5 and my 1, and see them right there. Let's try one with bigger numbers. Let's try 42 minus 29. You can see I have my cubes here with 4 10s and 2 1s. Sometimes I like to remind students that when I'm doing subtraction, 42 is the whole, 29 is one part, and I'm trying to find the other part. Because 42 is the whole and 29 is a part of 42, when I model subtraction, I only need to model the whole. My 2 parts are already here. So I'm going to take away 29, which I could do. That would involve a lot of counting back. I could also see that 29 is almost 30. So let's put these to the side and think about 30. If I take away 29, it's only 1 away from 30. So that means 30 minus 29 equals 1. So I'm going to take away 2 10s, 9 1s from 30. What's left? I have 1 10 and 2 1s from my original 42 and 1 from that 30 that I decomposed off to take away 29. So let's think about what this looks like when I write it. We started with 42 and we broke it up into 12 and 30. Then we took away 29 from my 30 and had 1 left. And then we had 12 plus the 1 left gave us a total of 13, which means 42 minus 29 equals 13. Let's try one more with even bigger numbers. Before we move on to 3-digit numbers, let's try another 2-digit number, but this time without the cubes to model. So we think about how we have 64, 10, 20, 30, 40, 50, 60, 1, 2, 3, 4. and we want to subtract 37. Well, 37 is almost 40. So if I break apart my 64 into 40, what's the other part? So once I take 10, 20, 30, 40 and put that together, the part that's left is, did you say 24? So now I'm going to take away 37 from my 40, and all I will have left is 3, because we know 7 needs 3 to make the next 10. Then I'm going to add my 3. So it's like I took all of this away except 3 on here. I have my 3 plus my 2 10s and my 4 1s. So 24 plus 3 equals 27. So 64 minus 37 is 27. Let's try 3 digits. Okay, this time we're going to try 421 minus 198. So let's think about when we picture 421, and we could draw a picture if that would help. 4 hundreds, 2 10s, and 1 1. I want to take away 198. What is 198 really close to? What friendly number? Yeah, this time, instead of thinking about tens, we can think about hundreds. And we could think about taking 198 away from 200. And when we do that subtraction, what's going to be left? Just 2 1s. So now we have 2 1s plus our 200s, 2 10s, and 1 1. So a total of 223. Let's think about how we could represent that using numbers and symbols. So 421 minus 198. The first thing we did was thought about the fact that 198 is very close to 200. So we're decomposing 421 into 200, and our other part was 221. Then we did 200 minus 198 equals 2, and we have to put that together. We could record that over here if we wanted to, just so we know we use that part, and then we have 2 and 221, or you can see over here we have 2 left and 221. So 221 plus 2 equals 223. So at first, when we're doing this with 2-digit numbers, this strategy might not feel super efficient. But when you think about what students would have to do to use the standard algorithm to subtract 421 minus 198, this strategy starts to look a lot more useful with larger numbers. In order to do this, I would have had to regroup and rename. So instead of 421, instead of 2 10s, I'd have 1 10 and 11 1s. But I still am not ready to subtract because now I don't have enough 10s. So I'd need to rename 100. So instead of 4 hundreds, 2 10s, and 1 1, I need to use 3 hundreds, 11 10s, and 11 1s so that I can do this subtraction. And then I will end up with 11 1s minus 8 1s is 3 1s, and 11 10s minus 9 10s is 2 10s, and 3 hundreds minus 100 is 2 hundreds. So think about the efficiency of being able to use this mental math as opposed to being locked into only using the algorithm.